Hi learners, come and join me once again to another session of fun learning. I am Teacher Jean and I am here to guide you in discovering quadratic functions. In today's session, you are expected to learn the following. First, model real-life situation using quadratic functions. Second, represents a quadratic function using table of values and graph. Third, represent a quadratic function using equation. So are you ready? Let's start. Quadratic function or QF is one whose equation can be written in the form y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. So just like in quadratic equation, our a must not be equal to 0. Otherwise, if a is equal to 0, we do not have a quadratic function. Rather, we are going to have a linear function. In an equation of a function, the highest exponent of the variable x is called the degree of the function. Thus, the degree of the quadratic function is 2. So take note, the degree of the quadratic function is 2. It must be the highest exponent of the variable x. Let us try the activity. State whether each of the following equations represent a quadratic function or not. So number 1, we have y is equal to x squared plus 2. Is it a quadratic function? Yes, it is a quadratic function. How about number 2? Yes, it is not a quadratic function because the variable x has an exponent of 1. How about number 3? Definitely, it is a quadratic function. Number 4. Yes, again, it is a quadratic function. How about number 5? Yes, the degree of the function is 2. So therefore, it is a quadratic function. So as you can see for number 5, we have two terms with variables x. The first term has an exponent of 2, while the second term has an exponent of 1. So therefore, since the highest degree or the highest exponent is 2, therefore we have a quadratic function. How about number 6? Y is equal to 2x plus 3x plus 2. Is this a quadratic function? Yes, it is not a quadratic function because if we are going to simplify the given function, we are going to have y is equal to 2x plus 3x, so that is 5x plus 2. So we have y is equal to 5x plus 2. Therefore, we do not have a quadratic function since the variable x has a degree of 1. How about number 7? Y is equal to 2x squared. Is it a quadratic function? Yes, it is a quadratic function. How about number 8? Yes, again, it is a quadratic function. Take note that if we are going to simplify the given function using the FOIL method, therefore we are going to have y is equal to x squared plus 2x minus 8, making the function a quadratic function. How about number 9? Yes, again, it is a quadratic function. It is a quadratic function because if we're going to simplify this side of the equation, we are going to have 2x squared plus x minus 6 minus y. Then we transpose y to the other side, making it a function y is equal to 2x squared plus x minus 6. And the degree of the function is 2. So therefore, it is a quadratic function. And lastly, number 10. Is it a quadratic function? No, it is not a quadratic function because the variable x has a degree of 3. Let's have a comparison between a linear function and a quadratic function. In a linear function, equal differences in x produce equal differences in y. However, in QF, when we say QF, it means quadratic function. So, in QF, equal differences in x do not lead to equal differences in y. Instead, the second differences in y are equal. The graph of a linear function is a straight line, while the graph of a quadratic function is a smooth curve which opens upward or downward, which is called a parabola. So take note, the graph of a linear function is a straight line, while for a quadratic function, it is a parabola. Let us have another activity. Follow the instructions below. Consider the given functions f of x is equal to 2x plus 1 and g of x is equal to x squared plus 2x minus 1. So what kind of function is f of x? F of x or function of x? The given function of x is equal to 2x plus 1. Since the highest exponent of our variable x is 1, therefore we have a linear function. How about g of x? What kind of function is g of x? G of x is equal to x squared plus 2x minus 1. The highest exponent of the given function is 2, therefore g of x is a quadratic function. Complete the following table of values using the indicated functions. So we are going to complete these two tables. Given first, in the first table, we have f of x is equal to 2x plus 1. So we are going to supply the missing values of f of x or y. So we are going to replace negative 3, negative 2, negative 1, 0, 1, 2, and 3 to the given function. So, if x is equal to negative 3, f of x would be equal to, that is 2 times negative 3, so therefore we have negative 6 plus 1, so therefore we have negative 5. If x is equal to negative 2, therefore we have 2 times negative 2, so we have negative 4 plus 1, so we have negative 3. If x is negative 1, we have 2 times negative 1, so we have negative 2 plus 1, so we have negative 1. If x is 0, therefore f of x would be equal to 1. If x rather is 1, our f of x is, yes, 3. Now our x is 2, our f of x would be 5. If x is 3, our f of x would be 7. How about letter B? We have g of x is equal to x squared plus 2x minus 1. If x is equal to negative 3, our g of x would be negative 3 squared plus 2 times negative 3 minus 1. So therefore, g of x would be 2. If x is equal to negative, our g of x. Yes, we have negative 1. If x is negative 1, our g of x would be equal to negative 2. If x is 0, therefore we have our g of x would be equal to negative 1. If our x is 1, what would be our g of x? 2. Very good. If our x is 2, what would be our g of x? Yes, we have 7. And finally, if x is 3, our g of x would be 14. Okay, so now that we have completed our table of values, we are going to use this in answering the third question. What are the difference between two adjacent x values in each tables? So what are the difference between two adjacent x values in each table? For our first table, table of function of x is equal to 2x plus 1, and for g of x is equal to x squared plus 2x minus 1. What is the difference between the two adjacent values of x in each table? So for table 1, what is the difference of the two adjacent values? Okay. Negative 1 and 0. Etong dalawang to, saka ito. For table 2, we have negative 3, negative 2, negative 1, 0, 1, 2, and 3. What are the difference between these two adjacent x values? We have, yes, very good. We have negative 1. To prove, we have negative 3 minus negative 2. So we have negative 1. Negative 2 minus 1 is negative 1. 0 minus 1 is negative 1. 0 minus 1 is equal to negative 1. 1 minus 2 is equal to negative 1. And 2 minus 3, we have negative 1. For the second table, we have negative 3 minus negative 2. We have negative 1 also. Negative 2 minus negative 1 is also equal to negative 1. Negative 1 minus 0 is negative 1. 0 minus 1 is negative 1. 1 minus 2 is equal to negative 1. And 2 minus 3, we have negative 1. So for each tables, the difference between the two adjacent x values is negative 1. For number 4, Find the difference between each y values in each table. So we are going to find the first difference in y for f of x is equal to 2x plus 1. And we're going to find the first and second difference in y for g of x is equal to x squared plus 2x minus 1. So for the first table, the first difference in y for f of x is equal to 2x plus 1. We're going to subtract the two adjacent y values or f of x. So negative 5 minus negative 3, we have negative 2. Negative 3 minus negative 1 is negative 2. Negative 1 minus 1 is negative 2. 1 minus 3 is negative 2. 3 minus 5, negative 2. And 5 minus 7 is negative 2. So the first difference is negative 2. For the second table, we're going to find the first difference in y for g of x is equal to x squared plus 2x minus 1. So we have the first difference, 2 minus negative 1. We have 3. Negative 1 minus negative 2. We have 1. Negative 2 minus negative 1, we have what? We have negative 1. Negative 1 minus 2, we have negative. Yes, we have negative 3. 2 minus 7, we have negative 5. And 7 minus 14, we have negative 7. So this is our first differences. How about the second differences? For the second differences, we are going to get the difference of our first differences. Okay, so we have 3 minus 1, we have 2, yes. 1 minus negative 1 is also 2. Negative 1 minus negative 3, yes, 2. Negative 3 minus negative 5, 2. Negative 5 minus negative 7, we have, yes, positive 2. So the second differences for g of x is equal to x squared plus 2x minus 1 is positive 2. So take note, in a relation, a one-to-one correspondence describes a linear function. So if there is one-to-one correspondence between two relations, it describes a linear function, while many-to-one correspondence describes a quadratic function. So take note, one-to-one correspondence is a linear function, while many-to-one correspondence describes a quadratic function. Also take note that in a quadratic function, y is equal to ax squared plus bx plus c. If our a is greater than 0, or if your a is a positive number, then the parabola opens upward. A parabola, take note, is a smooth curve which represents the graph of our quadratic function. So if a is positive in a quadratic function, the value of our a is positive, it opens upward. Otherwise, if a is less than 0 or our a is negative, then the parabola opens downward. Let us have quadratic functions in the real world. Parabolas are quite common in real world, like what you have seen on the previous slide. Many real-world problems can be solved using quadratic functions. One type of problem involves objects subjected to gravity. Their paths are parabolas because what goes up must come down. Objects that are launched, such as rockets, missiles, and cannonballs, that are thrown, or objects that are thrown, like basketballs. Objects that are kicked, like footballs, and objects that are hurled from slingshots, like Angry Birds toward a pig, all follow a parabolic motion. Analyzing the graph in each case can answer important questions like: what was the maximum height of the object? How far from the starting point did the object hit the ground? And how long was the object is in the air? All these questions pertains to quadratic function. Let us check your understanding. Are you ready? So what is the degree of the expression 5x squared plus 7x cubed minus x raised to 4? Yes, it is 4. Take note, when we say degree of the expression or the degree of a function, it is the highest exponent. So since our variable x has a highest exponent of 4, that makes this expression to have a degree of 4. Express y is equal to -3 times the square of the sum of x and 1 plus 4 in the form y is equal to ax squared plus bx plus c. Okay, the answer is y is equal to -3x squared minus 6x plus 1. So how do we arrive in this answer? We simply simplify this given equation or given expression, quadratic function. We simplify this given quadratic function. So we take the square first of x plus 1, then we multiply to -3, and then combine them to positive 4. Number 3. Which of the following table of values do not belong to the group? The answer is letter D. Why is it letter D? Letter D do not belong to the group because it gives equal differences in y. That means D is a possible linear function. Table of values for a linear function. While the 3 tables. Most probably, they belong to the table of values which represents a quadratic function. Which of the following graph describes a quadratic function y is equal to ax squared plus bx plus c with a is greater than 0? The answer is letter A. So take note, if a is greater than 0, the parabola opens upward. Okay? We cannot consider letter D as a graph of the quadratic function because we have this figure. So this figure isn't parabola. It is not a parabola. It is a curve, but it is not a parabola. The second and third graph, letter B and letter C graph, represents a quadratic function wherein our a is less than 0. Number 5. Throwing a ball, shooting a cannon, diving from a platform, and hitting a golf ball are all examples of situations that can be modeled by. Very good. Quadratic function. Number 6. Which of the following situation does not represent a quadratic function? Letter A. A toy rocket is fired into the air from the top of a barn. Its height h above the ground in yards after t seconds is given by the function h of t is equal to 5t squared plus 10t plus 20. Is it letter B, the maximum area of a house lot that can be fenced using 150 meters of fencing materials? Letter C, your height in meters relative to the height of the ski jump after t seconds is given by h of t is equal to negative 5t squared plus 12t. And lastly, the cost C in peso of parking a car in a busy downtown area for h hours is C is equal to 10 pesos plus 3 pesos h. Which of the following situation does not represent a quadratic function? The answer is very good, letter D. So did you get all the answers correctly? I hope so. That ends our session for today. Thank you and God bless. Happy learning!